In this video, let us discuss about two important close packing structures, hexagonal close packing and cubic close packing, which are actually three-dimensional close packed arrangement of atoms. We start with arranging the atoms in one dimension. This is done by keeping atoms one by one in a row along x-axis. In this arrangement, each atom is in touch with two neighboring atoms. So the coordination number of an atom in this arrangement is 2. Coordination number is nothing but the number of atoms which surround a particular atom in a close packed structure. Next, we shall extend this to 2 dimension. That is, we are going to arrange the atoms in z-axis. You can do this in two ways. First, we can arrange the atoms of the second row by keeping them exactly on the top of the atoms of the first row, or we can keep the atoms of the second row in the depressions of the first row. So first, if we arrange them on the top of the atoms of the first row, then we get an arrangement like this, which is called as two-dimensional square close packing, because each and every atom in this arrangement is in touch with 4 neighboring atoms, and if we connect all the 4 atoms, you get a shape of square, so that it is called as two-dimensional square close packing, and the coordination number of this arrangement is 4. Next, if we arrange the atoms of the second row in the depressions of the first row, then we get an arrangement like this, in which each atom is surrounded by 6 other neighboring atoms, and if you connect all the 6 atoms, you get a shape of hexagon. So this arrangement is called as hexagonal close packing, and the coordination number of this arrangement is 6. From these two arrangements, we shall take hexagonal close packing, and we shall extend it to 3 dimension by keeping atoms on the top of the atoms of the first layer along y-axis. Even though it is a close packed arrangement, we have spaces in between the atoms of every row. That type of space is called as a triangular void. So the vacant space which is present in the two-dimensional arrangement is a triangular void. We have so many triangular voids in this single layer of atoms. So first we shall locate all such triangular voids. And you also have triangular voids in the opposite direction, but we shall consider any one of the type of triangular voids and keep the atoms above such triangular voids. If we place the atoms above the triangular voids of the first layer, then we get an arrangement like this. If we take these 2 layers of atoms, we have 2 types of voids in between them. First type of void is called as a tetrahedral void, which is actually present in between one atom of first layer and 3 atoms of the second layer. We shall see here, we have 3 atoms, 3 blue atoms and 1 white atom. In between that we have a tetrahedral void. You can see here clearly This type of void is called as a tetrahedral void, because this void is actually surrounded by 4 atoms, and if you connect all the 4 atoms you get a shape of tetrahedron. And since it is surrounded by 4 atoms, the coordination number of this type of void is 4. The second type of void is called as an octahedral void, which is present in between 3 atoms of the first layer and 3 atoms of the second layer. It is surrounded by 6 atoms like this. So it is called as octahedral void, because it is surrounded by 6 atoms, and if you connect all the 6 atoms you get the shape of an octahedron. Since this void is surrounded by 6 atoms, its coordination number is equal to 6. And if a close packed structure has n number of spheres, that is atoms, then you may have 2n number of tetrahedral voids and n number of octahedral voids. And we shall locate the tetrahedral voids of these 2 layers. Now we are going to place the atoms of the third layer exactly above these tetrahedral voids. Now we have 3 layers of atoms. The first layer is mentioned as A, the second layer is B, and the third layer is similar to the first layer. It is aligned with the atoms of the first layer, so it is also A. So this type of arrangement is called as AB-AB arrangement, which leads to 3-dimensional hexagonal close packing. You can see here clearly, this is the first layer of atoms. We place the atoms of the second layer above the triangular voids, and atom of the third layer on the tetrahedral void. Then we get hexagonal close packing arrangement. And if you see, the third layer exactly aligns with the atoms of the first layer. So the first layer is A and the second layer is B. Third layer is also A type. So AB type arrangement is present in HCP. Now again we start with the 2-dimensional hexagonal close packed arrangement, and we place the atoms of the second layer on the triangular voids, and now we have octahedral voids. We are going to place the atoms of the third layer above the octahedral voids. You get an arrangement like this. For simplicity, we shall decrease the atoms of every layer. So the first layer is A, second layer is B, and the third layer is totally different, so it is C. But the fourth layer is now similar to the first layer. So we end up with ABC arrangement, which leads to cubic close packed system, which is otherwise called as face centered cubic system, FCC. So you can see here clearly 4 layers of atoms present in CCP. It is very clear that the fourth layer is exactly similar to the first layer. So you have ABC type of arrangement. Thank you.